and we started conducting a heavy research on Hyperloop applications. And basically what we're doing now is the first Hyperloop lab facility in the world, which basically allow people to do electromagnetic testing, building a smart algorithm related to traffic management, condition monitoring, and basically we're building our own digital twin as well for remote testing. To continue spreading the knowledge, as we're doing now in this webinar, we conducted the first Hyperloop summer school in Dubai. This was in 2018, in the summer of 2018. And this was the first version ever of Hyperloop-related summer school. And last year, we launched our experience design project, which we'll be talking about this session. And our eco-community platform, basically our eco-community platform is a platform for networking and knowledge sharing hub for different engineers and designers working on smart applications. Our main focus is smart mobility oriented projects, but also we want to spread this to different smart applications. I will mention it in before the presentation ends again. Those are partners we're proud of, and basically all these people help us conduct so many work and so many research. They have been supportive with data, with techies. We're working on innovative projects with access to materials and testing and so on. So for those who don't know what a Hyperloop is, this is a quick video to showcase a Hyperloop concept. This is our conceptual design for the Hyperloop. And if you don't hear the sound of the video, just someone comment. Only weak noise. So no one was actually hearing the sound in the video, right?
But it's very weak.
It's very weak. Okay.
But
we'll try to fix this one. Okay. Just if someone noticed like a serious problem. So this was a very, very quick review of a Hyperloop concept. As you can see, it's a very futuristic concept and it's still under development. However, the challenges in the system is the complexity of the amount of variables that you can meet and the integration between all the subsystems from the engineering perspective and from the design perspective are quite the challenge. So this was very, very interesting for us to continue working on, because working on such a complex system provides you with so much material related to so many projects. For example, working on the human-centered experience design and how to provide an interactive environment inside a Hyperloop capsule, which is very, very challenging, can provide you with so many ideas related to autonomous vehicle experience design, related to flying taxis experience design. So it's quite a challenging project, and it's still, of course, under development, but it was quite interesting for so many countries to start working on at the early stage. From this Hyperloop concept, we decided to focus on one of the main challenges in Hyperloop, which is the lack of access to testing. And that's why we were building the Hyperloop Lab facility to allow people to have access to information, to have access to testing. Because right now, around the world, the only place where you can conduct like a semi-appropriate Hyperloop testing is in SpaceX headquarters in Los Angeles. And it's not available for everyone. You have to compete in the competition and you have to be selected as a finalist, as we did in 2017, and build your own capsule and ship it to the USA so that you can maybe run a test in the, and it's only 1 mile trek. So it's quite a challenging environment to provide you with more accessibility to continue developing your own engine, your own structure, your own design concept. So the lab facility was designed, and it's a technology for Dmtech to basically allow people to have access to this technology and to provide data access to so many other subsystems that need the data to build their own monitoring tool, to build their own digital twin for other people to access the facility remotely, for designers to have something they can look up to and get data from to continue designing the product itself, and so on. So this is one of our main essential projects, is the Hyperloop lab facility. The second project is experience design and management, which is basically what we were going to be talking about today. But let me tell you briefly that our main aim from the experience design project is to drive a heavy research on different experience anatomy that can be applied for smart solutions, like smart mobility related solutions. As I said, this is our main concept, but also for data analytics and for other purposes related to space oriented projects, like the space inhabitants design. Last summer, I was giving a session in the UK about mobility on Mars. So these kind of case studies require very heavy experience and modeling, so that you can actually acquire more data to provide to the R&D people. So in this process, the engineering and design are very, very integrated, and they work in parallel tracks. The third project is the Eco Community Platform. As I said, the platform main purpose is to provide data about complicated and complex solutions, also in the smart mobility domain. But again, we want to include more projects in it. The Eco Community Platform right now is a hub where you can access information related to the Hyperloop, which is a very rare thing right now, and to allow you to access to a network where you can about any challenging problems you have in the engineering design or in the industrial perspective of it, and you can access other companies working on the same solutions you're doing, and so on. And now we'll move to why experience design. Well, as you can see, like most of the things we'll be talking about is a very complex tech-oriented project. So if you have any tech-based solution, let's take, for example, the Hyperloop we're talking about. It's a very heavy technology included in the solution, and it basically integrates so many systems. It includes electromagnetic complexity, where you want to provide levitation and thrust from a single electromagnetic engine, and at the same time, it has complexity of structure going under heavy vibrations and a closed environment and pressure difference and so on. And at the same time, you're integrating the experience element of it. So the interior design, what would people be doing inside the capsule, the kind of visuals they want to see, how to reduce the forces on the human body, and so on. So all these complex subsystems are integrated in a way for a solution. So you want to conduct research and development individually for each subsystem, and at the same time, you want to integrate them together to have a well-designed product. And then you start testing your product. So you do individual testing as well. Like, for example, you may test your engines, you may test the VR kit you will allow people to use inside the capsule. You may test the seat that the people would sit on, but after all, you will integrate these subsystems and conduct a product testing. When you do the testing, you expect to have a first feedback, which will influence the product. So, for example, the seat fixation with the interior needs further enhancement. But also there is a second loop of feedback where it influenced the research itself. So you go back to your researchers and ask them to go further in the possible, let's say, attachments that can be added to the chip, because when the user tried the seat, they didn't feel comfortable when they laid their head down, for example. And then you have a third feedback loop, which influence the development. So from the research, you conclude that in that case, I will need to do further development on the seat, and I will need to change some parts of it. All these feedback loops can help you to reiterate on the testing and conduct more and more iterations where you finally reach the optimization phase. The one common thing about all these feedback loops, it's user-centered feedback. So without a user and without the human feedback, you cannot really have a proper feedback loop. And we have seen this in so many solutions. We see people, sometimes they launch product in a market that they didn't conduct enough testing with respect to the user feedback. So after putting the product out there in the market, you feel like there's something missing, and you have to change the product, or you have to optimize more on it. And of course, sometimes this is beneficial for the business aspect of it. This is not our topic today, but also this is in a very heavy R&D oriented process. The feedback is very essential, especially if you have a sample group of different, or you have a defined user group that you will test on. So that's basically why we were focusing on experience design from a human-centered perspective, and then we'll move to the methodology of our research. This methodology was a conclusion for a one-year research we conducted on experience anatomy for smart mobility solutions. And the main concern we had is how to develop a full design methodology where the human is the center of each step of it, from the research and the data collection about your own solution to defining the design elements and building an anatomy. For these design elements, we will see a case study for this one. And then integrating different technologies to help optimize on the process. And then the decision evaluation metrics, which is one of the main challenges we face as an engineers. For example, when I was working on a Hyperloop, I didn't have any reference for what would make me decide that this would fit much for this kind of user groups, or it wouldn't. For example, if I'm choosing a seat for a capsule that's running with a speed almost equal to the speed of sound inside a vacuumated system, what reference can I use to tell this decision of selecting or designing this seat would work more appropriately than this one? Or what would help me to for example, to select an interior of a certain material that would work better? What would tell me that the carbon fiber is much better than the fiberglass for the seat, for example? These kind of random, and as random as I mentioned it now, this kind of random and collect and integrating variables are not placed in a way for the new solutions, especially for the new ones. We don't have access to this kind of evaluation metrics that will help me to go through the variables that I need to think of. So I might be an engineer working on a solution. I might be a PhD student or a master's student that I'm working on my project, and I don't know what I'm missing because I don't have a certain metrics or a certain evaluation tool that can take me through all the elements or all the variables I need to take in consideration. And in smart mobility specifically, where we conducted our research, this was the main objective of the research, to come up with an anatomy that will help any designer or any engineer to go through all the elements that would cover an optimized and a healthy experience for the user. And then, of course, testing and taking the feedback from the user. So this is a customized, as I said, a customized methodology we used for the smart mobility. What we did is that we took a certain desired case study. So we were focusing on smart mobility and the challenging solutions in the smart mobility. So we chose the Hyperloop, and then we started defining the system specifications. So for a Hyperloop system, I have a vehicle, which is a capsule that the people ride in. You saw on the tube. I have the tube that the capsule runs inside. I have the station, the interior of the Hyperloop capsule, the navigation inside the station, these kind of elements that the user would be exposed to. And then the second thing is, okay, I want to build an experience anatomy. I want to put all the elements in one structure that I can go through and analyze my design process. And then we now have the environment, we have the elements, we have the variables I have in the system. I want to see what kind of needs and expectations someone who would ride a Hyperloop would have. So this would require, at this stage, it's not just our research and development. It's also, I need some statistics. I need to do some evaluations. I need to collect opinions. So we did a survey for the public about. We conduct about 100 feedback survey from different user groups. If you are riding a Hyperloop, what do you need in it? If you're going to the Hyperloop station tomorrow, what your expectations would be? And then we collected different expectations and needs. But also you can, from the research, you can evaluate the main needs. Like of course, safety would be one of the main concerns. If I'm telling you you're going inside a capsule that will run inside a tube with a speed almost equal to the speed of sound, or very close to it, you would wonder about your safety. Am I going to live from this or not? So these kind of basic needs can be acquired from research, of course. And then after putting the human elements into the picture, we thought, okay, it's a futuristic solution, then there has to be technology integrated based solutions that can optimize the experience itself. And at this stage in our lives, technology is developing so fast, and the applications, we cannot keep up with the applications, but integrating these applications into solutions that are existing or will exist is an essential part of the design process. So you as a designer or as an engineer, if I'm working on a project that will be implemented in 10 years time frame, then I need to know in 10 years that the technology expectations would be so much different. So I cannot tell people that you will have a TV screen inside a Hyperloop capsule. It's unacceptable. Even if it is now, it won't be in 5 years. So it definitely won't be in 10 years. So this kind of futuristic integrated mindset needs to be in the picture now. And then, of course, the testing and feedback for a non-existing system, which was our challenge. So we're working on a futuristic case study. So we don't have the actual test bed or it's not safe enough to put a human in it now. So what we can do is we can build a virtual testing tool where people can use this virtual tool or we can use it to collect feedback and data from the user trials. So this was a methodology in our research. And now I'll take you through the anatomy of the experience itself. So this infograph you see is basically the main result of 1 year work. The passenger-centric experience in a case study like the Hyperloop was so generic. However, the objective was to come up with anatomy that can be applied on any smart mobility solution. Again, the case study was on a very complex system, but we wanted to come up with an anatomy that will help designers and engineers working on any smart mobility-based solution. From a passenger-centric perspective, the anatomy had 3 main elements. The number one is the prearranged experience architecture. So it is basically all the steps you will go through as a user before arriving at the station or before using the vehicle. So it can has the booking and ticketing, the accessibility for the information itself, and the accessibility to the solution itself. Because not all smart mobility solutions, like for example, not all flying taxis will be accessible for all kind of use. So these kind of studies need to be conducted by the designer and engineer before carrying out this solution to the public. And the second pillar was the station navigation. So all the things that a passenger can be exposed to in a station, whether it's a bus, small bus station, or it's a hyperloop station. So, you know, the basic elements of a station experience is the check-in process, including all the elements inside the check-in. So the passenger, the luggage, the handling of his equipment or his tools, the station facilities. So what kind of facilities this solution needs to be existing in the station, the checkout process, and of course the accessibility. The third pillar was the vehicle experience itself. The vehicle accessibility, the vehicle facility are integrating with the station, but also we can see the environment and spaces as an element inside the vehicle itself. These kind of charts are, they may seem like, oh, okay, it's an idea, but for a designer and an engineer working on something that doesn't exist yet, I don't know what to take in consideration and what's essential for the user to be there. So the objective of these walkthrough kind of charts is to help you take all the elements in consideration, and then it's your call as a designer or as an engineer to neglect or give less weight to certain elements. So if it's for example, if it's a quick bus station, so you don't need to have facilities, you don't need to have a toilet at the station, you don't need to have a cafe near the station. Just a shared bike, for example, a shared bike, a smart bike station.
Sorry, reconnecting Summer. We lost. Yeah, she's coming back. Okay, Summer.
Yes.
Lost you for one slide, so maybe you need to go one slide back.
Oh, okay. So can you see my presentation now, or?
Yes, yes.
Perfect. So one slide back. That's the one slide back. We will just now move to the tech integration in experience anatomy. So I was saying that we focused on 5 main technologies because they were so trending in the current technology graph, and so many startups working on smart mobility solutions are focusing on certain developments. So for anyone who's interested in any of these 5 technologies, know that there are so many companies looking forward for someone who would help using these technologies in optimizing their vehicle experience, or even the vehicle performance from the traffic management perspective of it, or from the monitoring perspective of it, or the data acquisition perspective of it. What we did is that we took the 3 main pillars of the experience in the smart mobility domain. So the pre-arranged experience architecture, everything happens before the use of the solution, the station part of it, and the vehicle experience of it. And we reflected through, this was one of the very complex research we did. We collected information about all possible smart solutions, like including airplanes, current autonomous vehicles or semi-autonomous vehicles under operation, electric cars, electric buses, maglev, high-speed trains, how all these solutions are using, if they are some of these technologies, and the expected performance of these technologies in the future experience of the coming solutions. And we reflected the weight of each of these technologies on each step of the experiences. So, for example, you can see in the booking and ticketing, the dependency on the artificial intelligence and the blockchain and the Internet of Things is much, much higher because this is a data process. People need to access the data, save their data, and send back to the system their booking data. So it was mainly dependent on this. But if you move to a step like the navigation experience, you can see the dependency on the Internet of Things, the AR and the VR are much higher because this is a visualization. The navigation process, more than 50% of it will be depending on the visuals inside the station or the virtual visuals that you will include. If you told people that they can have their map through an AR tool or an AR application, so they are using the augmented reality to go around, then you're semi-implementing a virtual visuals that doesn't exist, but still the dependency on the visuals is more than 50% because if you are in an airport, most of the time you're just trying to find your way or you're lost. So this is basically a sample for how these technologies can fit each step of the design. And again, this index main objective is to help designers to face the challenges with possible solutions in these technologies. And instead of digging in from scratch, you can easily, okay, I have a problem in the navigation. Okay, how can I make it futuristic? To think about it much, you just have to take in consideration that this kind of virtual reality tool can help you build it, and then you start build your own ideas, or at least organize it. Then we'll move to the experience assessment. Our assessment was based on four main, we call them the 4 A's. So from the surveys we conducted and from the research we have carried out, the main elements that the people focus on and the main needs for a user is that it's always available. So whenever I want to go from A to B, I don't want to wait 30 minutes or hear the word that it's unavailable. You cannot be in the future. Everything is so smart. Everything looks so good. And you tell me that you're saving me, you're building a system that can run almost to the speed of sound. And you tell me that I have to wait 30 minutes for my bus. The accessibility, it's one of the very heavy, challenging problems, and mainly designers were very oriented about accessibility a long time ago. How can we make all the solution accessible for all kind of users? And affordability, of course, and the acceptance, which is it's more of a it takes much more than just design and engineering at this stage. It takes the social impact of it, the environmental impact of it, and the background of the community you're building the solution for. This is also needs to be taken in consideration. If you're building something, if you live in Norway and you were asked to travel to China to build to help design experience or to help solve a challenge in the traffic management of the maglev or the any of the high-speed trains, you cannot treat the Chinese users, the kind of community using this solution, the same way you treat people in Norway. So you cannot expect the same needs. You cannot expect the same kind of expectations from the user. You have to take in consideration the acceptance level that these people will look up to or will look for. And the framework of applying these 4 A's is basically through the software elements, so all the human elements, as I said, like the acceptance affordability for the user itself, and the product elements, because the cost of the product, the operation of the product, and the acceptance of this product to apply this design solution. For example, to clarify, you may say that, okay, people are expecting to wear VR goggles inside the autonomous bus so that they can have a nice experience during the ride. But in the bus, you don't have power access to charge these VR, or you don't have a smart infrastructure where it can help people visualize different or customize their experience or choose from different experience. It's the same experience and everyone will be forced to watch it. So the acceptance also can be from the hardware perspective, and the governance, which basically includes all the shareholders on the solution, from the provider to the government to the people responsible for the operation to the users. Well, we looked at the experience assessment from a different perspective, which is how can we use the quality of experience? And when quality of experience, it's different from the quality of service. The quality of service is the expected performance of the service for the user. But the quality of experience is an integrated expectation from the designer and the engineer working on the solution and the provider vision of it and the authority vision for it and the user as well. So it's so many elements, takes so much in consideration. And in our current state of art, there is also in the context, you can see the environmental aspect of it is the must take in consideration element. It's not a privilege anymore. So what we did for the quality of experience is again another guideline. So you take the passenger profile, no matter what kind of user groups you were able to include, but you have a certain profile you're taking consideration. So you put in consideration the emotional, mental, and the expectations states of it, and then you influence these profiles to help you to come up with the human influence factors part of it. And then you take also the system influence factors, and this can be the kind of technical specifications of your solution, the availability of the solution, the operation process, is it smart enough or not, and these kind of elements. And then you take the context influence factors, which is basically everything related to the infrastructure, everything related to the city, everything related to the environment of the operation. And then you can add weights to each one of these elements. And we're building our own algorithm for this one, where we aim to use the user data and the feedbacks to generate the passenger profile. So imagine all the work you need to do just to get enough data so you can build the human influence factor block. Because the blocks can be easily concluded at the first iteration, at least. You can conclude it from your own system because you're designing the system. But the human influence factors cannot be expected for a non-existing solution. So it will need to have a certain data generating product. And a data generating product needs to be virtual because the solution doesn't exist, or it's not safe for public use yet. And this one challenge will take us to the role of VR in this kind of state. So as you may conclude from my, I repeated it so many times, I can conclude it's basically the VR role in our case here is to help us conduct the feasibility study. So I have a project. I'm giving you an idea, and I'm presenting to you my project is about mobility on Mars. And I'm proposing a certain magnetic solution for people to move in Mars from one inhabitant to another. And I'm proposing my idea, but I have no idea if it's feasible or not. So luckily now we have enough tools to help transform my calculations, my thoughts into an initial design, build a mathematical model for it, include all the system dynamics from my proposed engine or my proposed system, and then using the 3D model of the experience, we can put all of this together to conduct a certain simulation where people validate the results of this simulation. And after putting all the elements together, you will ask me to bring users. So we'll bring astronauts and ask them to put on the VR and collect their reactions, their facial expressions, their body reactions. We collect their verbal feedback, acquire all their expectations, and then include it again in the system and reiterate. All of this wouldn't have been possible if we didn't have tools like the VR. Back in time, we used to simulate to run the simulations on our computer, but the true and the sincere feedback of a user wouldn't have been possible if we couldn't immerse the user inside the experience. And this is now possible through the VR. And this is the main objective why we're using VR. We're not using VR in our company to build a nice visualization or for gaming purposes. We're basically using it for to help optimize our development and to collect more data from the users. So as I said, in our process of design, we don't just build a nice visual, we conduct a mathematical model, and then we include all the system dynamics resulted from our engineering work. And then our architecture and design team conduct the 3D model part of it, and then we integrate these to have a proper simulation where we can analyze all the motion, the visuals, the expectations, and then open it to the public where we can have more data. The first case study for our project is that the Hyperloop Lab facility I told you about in the first slide is that at this lab we wanted more people to be able to use the lab virtually, and also to help students and researchers to try out our lab and tell us what's missing. So the first trial to visualize the lab was to draw a sketch, a hand sketch, and turn it into a 360 experience, as you can see here. It was a very basic tool to see how our lab would be like and what kind of elements we need to include in the lab. And then we took it further to build our own lab model. And now you can actually use our VR and go inside the lab and interact with the components of the lab. You can use the test bed, you can run a test. You can, inside the VR, you can interact with the components inside the lab. You can try out the capsule. You can view the architecture work and run simulations. And the VR role, you can see in the slide. Let me use the laser. You can see here a digital twin and the virtual reality experimentation unit. These two are here differentiate between the role of visualization for a nice experience and the role of visualization for data acquiring and data monitoring and data transmission. And it's just how much smart it gets after a nice visual. So you have a mathematical model, you have a 3D model. You can take it further to transform it into a smart system that can help you remotely monitor the lab or access the testing remotely, or you can just leave it for the aspect, the design aspect of it and the user feedback for the design. Is it appealing enough? What elements are missing? And that's it. And the two units are included in the lab. The second case study is that we built a Hyperloop station experience, and this is actually the first ever experience that was done for Hyperloop. So now you can wear our VR and go inside the Hyperloop station and experience how it feels like, what kind of elements you expect there and everything. And now I'll show you a short video for the walkthrough. So you will walk through the Hyperloop station and see what kind of elements are part of this Hyperloop system. Let me play the video.
Welcome to the first Hyperloop station.
This was basically, of course, it's much better inside the VR, but I wanted you to see the walkthrough that we experience inside the VR now. This is the first iteration for the Hyperloop station, and we were planning to open it to the public this month, but according to the global situation, waiting so that when things get safer, hopefully we will open it to public. So we'll have different users poking the trials, and they come to our lab to test the VR. And from at this stage, we can start collecting data about the user expectations, what's missing in the experience, what they look for. And now we'll just move to the concluding remarks. Basically, our focus from the experience design part, because we started off as a very techy people. So we were doing electromagnetic related work, system integration, aerodynamics, mathematical modeling, algorithms for traffic management, algorithms for conditional monitoring. But very soon realized that the design aspect of it is a very important essential part track that needs to be running next to the development. So our focus from the design, experience design, is related to our focus in development, which is smart mobility applications, conceptual design for smart city, and the city of the future, and the space inhabitants. Those are the three main applications we're focusing on from development and design perspective. The use of VR for us is basically to help optimize our R&D and also to collect data that can feed our smart algorithms. The existence of the Eco Community platform, which I didn't talk about much, is to help provide more information through our work to people and share our information and share our data with the public, and also to build a very strong network of developers, researchers, students, professionals, industry, industrial to look at each other's work and integrate their data and hopefully cooperate as well. And also, we are planning once our digital twin reach a mature stage, we will open the simulator for public. The reason why we're giving you this presentation, because as a student myself, I know the need for ideas. I know the need for integration with up-to-date development happening, and the kind of need in the tech world now, and what's missing in the market. We did this presentation to share with you our projects and our work and help you generate your own ideas. And if any of you is interested in any of these projects or have any questions, of course, I'll answer your questions. But if any of you is interested, I will discuss with Dr. Ibrahim. We're open to have to provide internships. We're happy to support with our know-how. We're missing Dr. Khamis. He's our co-founder, and he's an AI senior expert. If any of you felt the need for supervision or help or support or just an advice, we're here for you. And now I'm ready for your questions. And thank you.
Thank you very much, Summer. It was a very nice presentation. So, in fact, I have a comment because we have simulation and visualization master program, and it answers one important question: what kind of future product which we can test? I mean, usually people ask you, how can we use simulation and visualization? So your presentation today answers a very important question. If we need to test mobility on Mars, for example,
Yes.
or if we need to test a product which does not exist at all, so we need to use simulation and visualization to test it. Yeah.
Yes.
Mm-hmm. So, any question to Summer? Colleagues, students, any question to Summer, please? Mm-hmm. So,
if any of you is feel like something is missing, if you feel like there is an information that wasn't clear, don't be shy. Just ask me what's missing, and my email is already in the slide. If you feel like I tried to share my video so that you can see my face. Maybe this would help you.
in fact, I also I recorded the webinar today, so we will share it also with people. and also we will share your contact information. And if you can share the slide with us, it will be nice. If you have some links to the, I mean, those videos which we couldn't hear clearly, if you have some YouTube videos for it, it will be nice also to share it with us.
Yes. Oh, actually, I want to say that we haven't put our work in public, and this webinar is the first time we share our work with the public. But it's a pleasure for me, and yes, we will share the presentation and the material with you guys. And if any of you have thought of questions later on, I'll be glad to answer any. You just send me an email. I don't mind.
In fact, we have some students from simulation and visualization. So I would like to ask them if any one of them has any questions. For example, if there is something which he would like to work in the specialization project or in a master thesis. Nicolo, is there any questions from the second year or first year master students?
Not from me. I think this project is an interesting project, and I hope someone will deal with this. I have already found my master thesis, so I'm not the right person, but I hope someone else will join.
Yeah. Eric, any questions? Emily? So as long as we don't have more questions for today, I guess we can close it
Yes.
at that moment. Harald, do you have any questions?
Yeah. First, I think this was an interesting futuristic idea. But the question is to implement this idea, you have to relate it to some practical situations. So
Yes.
where do you think you will implement this? Is it between towns? Or
Yes.
have you actually towns or cities that you will implement this? This is one question. And the next question is, what will you optimize? What is the optimization problems? Is this traffic flow, or is energy, is it safety, or what is this? Because there is so many things to optimization. So what is the key ideas of to solve the optimization problems?
Thank you so much, Harold, for asking this. I'll answer the first question because it's easier. The implementation of our work is not just related to the Hyperloop. As I said, we use the Hyperloop as a case study because it's a very complex solution. So all the resulting output from the work on this system fit into so many other solutions. So for example, the work we're doing on the electromagnetic system itself, the engine, to have an electromagnetic engine that can do thrust, high-speed thrust, and levitation at the same time. This application is used for in heavy industry, and it's used for space application, and it's used for military applications. It has so much more beyond the Hyperloop only. The experience design part of it, some startups working on autonomous cars, for example, the lab in Carlos Third University in Spain, they have to design the experience for their autonomous car. So they're building their own autonomous vehicle, and they need someone to build the experience of this vehicle and help them build a monitoring. A kind of it's a mix between a conditional monitoring and a predictive maintenance engine in the vehicle itself, to acquire all the performance data and optimize on the batteries and everything. So the implementation of our work is not just related to the Hyperloop, because the Hyperloop is very futuristic, but it also fit into so many other applications related to the smart mobility, or basically some space applications. Or this is what we hopefully look for. And of course, the lab facility objective is to provide testing facility. where people can conduct development, because it's a very critical domain and no one have access to a facility. Most of the countries working on Hyperloop now, they don't have a test track where they can test their engines or their vehicles. The second question, Hyperloop concept, it has so many challenges. It's related to safety because of the pressure difference. So because some solutions are proposing that it's vacuum inside. So if you have a vacuum inside, atmospheric pressure outside, the tube may collapse. So it's a safety problem. It has some challenges also related to the traffic management. The traffic flow of electromagnetic systems is a different problem from the on-ground vehicles. Same as airplanes. The traffic problem of an airplane is different from the traffic problem of cars. So, so if any of the students here are interested in working on this problem and help visualize it as a simulation, I proposed before to treat the traffic flow of a Hyperloop capsule like a fluid problem. So you can treat each capsule as a particle. So it can get really scientific if you want to. And you would be the first to propose a traffic analysis for it. So the challenges are so many. That's why we're working on this system, because it's very challenging, and the output can fit in so many solutions. The Hyperloop is still under development. Everyone now is working on the engine because it's the most challenging part of it. The structure and the body and the tubes, we did airplanes, so we can do this also. But the most challenging part of it is having an electromagnetic engine that can provide thrust and levitation. And of course, the human, anything related to the human element is still under development, including the experience, including the traffic flow, including the monitoring of these vehicles. So if anyone feel like there is a part where he can focus on, you will be the first to do this, believe me. So you can take the lead, and we would love to support you with information or material.
Are you thinking about to make a simulation models, for example, making two virtual cities, and then
Yes.
integrate the traffic between two cities? It will be easy to do this in Unity, for example.
Yes, we used Unity in the beginning, but now we're using a 3D perspective. The case study we used here is how the new solutions like the Hyperloop can help revive a remote area. So if you have in Norway a case where you can see the desert background in this case study. So we took the Hyperloop to an oasis in the middle of the desert, and how the implementation of this solution in the middle of nowhere can help revive this area and connect, and how it will change the traffic flow from the city. So if you have a challenging part in Norway where you can conduct the same simulation, believe me, we did this case study for Dubai. The governments are really, really interested in this because it's one of the biggest problems they have. So I'm sure your university has a lot of connection where you can get some data, and you can, if you have two cities, a challenging city, one is in a remote place, and it's very, it doesn't have tourists, for example. It's a very normal and basic city, and you have a very high flow city. You can connect between them and run a simulation to see how this can change the city behavior and the human behavior. And there is so much to take in consideration, believe me. Like, you can run this research for years and never run out of updates and development. So yeah, you know better if you have a case in Norway, or you can work with the students where they can conduct these kind of simulations, and they can focus on the part that's more interesting. They can focus on the human behavior of it, or they can focus the engine, or the system integration, or the city traffic flow. You can choose what part to focus on in the beginning.
In fact, we have lots of projects in smart city, and it's a very hot topic nowadays. So I feel, this Hyperloop, it's very relevant, in fact, to the research in smart city. So, yeah.
It could be an interesting idea to try it.
Yeah.
See as an application compared to another application.
Exactly. It can be a feasibility study tool. You can conduct a
Yeah.
feasibility study for the smart city government, because I know Norway is doing a lot of work related to smart city. So you can provide them with we're doing this with the Cincinnati University in the US now. We're doing this for Ohio State. So the Smart City Council, they want to do a feasibility study for the different vehicles and the different solutions. So you are a visualization and simulation lab. You are the best to conduct this kind of studies.
Yeah, in fact, our simulation and visualization, we have a lab in the same floor close to United for Smart City Lab in Olesund. So it's a very
It couldn't
strategic
get
place.
easier. Yeah,
Yeah, of course.
that's perfect.
Yeah. Yes, thank you very much, Summer. Is there any other question for today? So I guess yeah, thank you very much for today. It was very, very exciting presentation today, and I wish we can have another meeting in the near future so we can try to define some small project for our students. And as I told you, we are connected with Smart City Lab in Olesund. It's a very strategic place, in fact, and they have huge resources, and they try to invest a lot in smart city research. And I hope in the future we can have another meeting, and try to define some projects and continue working. And we need to see how can we work together in this project.
Hopefully, yes. Yes, I hope so.
Yeah.
Thank you, everyone, for showing up, and I hope you had at least a refreshing presentation. And yeah, if anyone felt like questions later on, just email me. I'll be glad to answer your questions. Thank you all.
Thank you very much. Thank you
Thank
very
you,
much,
Dr.
Summer. Thank you very much. Thank you. Have a good day. Bye bye.
You too.